Explain working of move type distance relay. So for the better understanding of the working, the figure is included here for the better understanding, and the mathematical explanation is given. The theoretical explanation is already given with the working or say constructional details of the move type distance relay. This calculation can be easily understood with the RX diagram that we will see later on. The operation of the move relay depends on the balance of different torques generated within it. So operating torque T operating, that is TO, this is produced by the interaction of the polarizing flux and the flux produced by the operating current here. This operating coil is energized by the CT secondary current. So the torque produced is given by the following equation, that is TO, T operating is equals to K1 is the constant, V is the voltage or system voltage, I is the current or CT secondary current passing through this operating coil, into cos phi minus alpha. So V is the voltage, I is the current of the CT secondary, phi is the phase angle between the voltage and current, that is our power factor angle phi, and alpha is the maximum torque angle. So the difference between these two angles and the cosine of this angle is multiplied with voltage and current will give us the operating torque. Restraining torque TR is here. Restraining coil is directly connected with the system voltage. So restraining torque is naturally produced by the system voltage. So it is produced by the voltage coil, and the restraint against operation and is proportional to the square of the voltage, that is TR can be given as constant K2 V square. Now spring restraining torque, that is the torque produced by the spring mechanism here, mechanical torque. There is also a small restraining torque produced by the spring and denoted as K3. However, because its value is very small, it is usually neglected when the practical calculations are considered. For the relay to operate the trip in the circuit, or say the relay must operate during the in-zone fault, the operating torque must be greater than the restraining torque, and this restraining torque is a combination of the electrical restraining torque plus spring restraining torque. So can be given as mathematically K1 V into Y cos phi minus alpha greater than K2 V square plus K3, and K3 for the practical calculations neglected here. So the result is K1 Vi cos phi minus alpha greater than K2 V square. Now if we rearrange the term and divide the equation Vi K2, so K2 into Vi both the sides, so the resultant or the equation may be rearranged as K1 by K2 cos phi minus alpha must be greater than V upon I. Now V upon I is the ratio of the voltage to the current is impedance Z. So we can substitute the value Z. So the equation value Z is can be written as Z less than K1 by K2 cos phi minus alpha. Now the term K1 by K2 is a constant representing the ohmic rating of the relay, often denoted as ZR. So the relay will operate when the measured impedance Z falls below the threshold value, means the impedance value must be less than the actual characteristic impedance or the value of the impedance, or say this term ZR cos phi minus alpha. In this condition the relay must operate. So this is all about the working of the move type distance relay. This is mathematically working, and the theoretical working is already explained with the constructional details.